All right, new content, Chem 30. Organic chemistry. The first thing we need to do is define what organic chemistry is and have an understanding of that and how it's going to apply to the stuff that we're trying to do. So, up at the top, the definition that I've given you in your notes is that organic chemistry is a major branch of chemistry that deals with compounds of carbon. That's the first key. All of organic chemistry is based on carbon. So, underline that term, put a star by it, whatever you need to do. But if something doesn't have carbon in it, it's not organic for the term, for at least for the conditions of what we're talking about here for Chem 30. So, number one, it has to have carbon. There are some exceptions though. There are some carbon-containing compounds that we don't consider organic, and that's what you need to know for these exceptions listed here under B. The first one is the carbon oxides. Pardon me. So for this one, the carbon oxides would be carbon dioxide, CO2, and carbon monoxide. Those are really the only two that you need to know. But just know that if you see them, even though they have carbon, these are not organic molecules. Okay, they are an exception. And the other one is anything that's ionic that contains carbon is also not organic. So I've given you three here. So carbonate, for example, which is CO3 2 negative. If you see that in a molecule, a cyanide, which is a Cn negative, and carbide, which is a little bit harder to find, but it's a C2 2 negative. If you see any of these things in something, essentially if you see carbon in an ionic compound, it is not organic. So let me see if I can give you an example here. All right. So here are 4 different molecules, and this is a really common type of question you might see on a test or a quiz, is to identify out of this list which molecules would be considered organic molecules and which ones would not be. So the first thing you should go through and look for any molecules that don't contain carbon. In this case, that means that we can eliminate the NH3, the ammonia, because it doesn't contain carbon whatsoever. Everything else contains carbon. So now we start looking for our exceptions. Do I have any carbon oxides? In this case, I do. I have carbon monoxide, and I know that carbon oxides are not organic molecules, but that's the only one. Next, we start looking for ionic molecules. This can be a little bit tricky, although once you get the hang of it, it's not too bad. The most obvious one here most obvious way I say to look for these is to look for metals. So for example, here I see sodium and I see cobalt. Anytime I see metals attached to nonmetals, I know that that bonding is most likely going to be ionic bonds, and I can see here the polyatomic carbonate and cyanides that I know are not organic. So I can eliminate those two. Now, ones that sometimes give people trouble are the ones like this OH here and this acetate ion here. Sometimes students will see those and think, oh, well, that means it's an ionic hydroxide or an ionic acetate. Those are not ionic bonds, though. If that was a OH attached to a metal, then yeah, that would be ionic. But since these are all nonmetals attached to each other, in both of these cases, these are not ionic compounds. These are molecular compounds because it's all nonmetals. So because of that, all 4 of these do contain carbon. They don't fit our exceptions, so we would consider those organic molecules. So that's the first skill you need to know. You should be able to look at any molecule and identify, is that organic or is it what we would say inorganic, or at the very least not organic, from a list of molecules. And I can almost guarantee you you're going to have a question like that on a quiz and most likely probably on your test as well. So that's the first skill you got to make sure that you have for this unit.